Now, when I run the PowerPoint, is it moving?
Yeah, it's moving.
Okay, then we are together. So let us understand what are the characteristics of a network. Any network created will be created for sharing of resources. That is one. These resources could be file, there could be just messages, there could be information, whatever it is. Also, resources could be like the physical hardware, printers, scanners, computers, the computing power, which is available on the network. All of that are characteristics of networks. In a network, there is what we call the communication model, where there is a source system and a destination system, and in between we have the transmission system. The source system will have the source and the transmitter. The destination system will have the receiver and the destination. The work of the source is to generate data so that it can be sent. The transmitter, it will convert this data into transmittable signals. Like we will see in a while, we have to understand this data will be converted in different formats as it is prepared for transmission, then it is transmitted, and you are able to get the message at the end. Then the transmission system will carry the data. The receiver will convert the received signal into data that can be read by the user, and then the destination will take the incoming data. So that is basically the communication system. And as you can see in slide number 6, this is the first presentation we are going through. In slide number 6, it shows how text is translated into a digital bit stream. Then the transmitter translates it into an analog signal that is sent through the network until it gets to the receiver. The analog signal will be changed into a digital bit stream again, and then the destination. For an example, like a modem. When you're using a modem on your laptop or you're using it on your mobile phone, the source will be presenting or the source will generate information like a video or an audio or a text message. That is a digital bit stream which has been generated. Now, the work of the modem will be to translate this digital bit stream into an analog signal that can be transmitted through the network within different devices across. It gets the receiver, which could be a modem or it could be a router or any other device at the recipient. Then it is translated back, that analog signal, into a digital bit stream, which now can be become a video or an audio, which now can be translated or can be read by the user. So that is the communication model or the communication system which we had referred to at first. So I hope that is clear to everyone. Are we okay? By use of comments, I would like to know if we are okay, or maybe a comment. Yes, thank you, Gitao. At least I understand that we are together. Yes, thank you, Ron and Agri. Thank you. So let us proceed. After understanding the communication model, we also need to understand there are different communication types which take place in this data communication system. One of them would be a unicast. When we are talking about unicast communication, we are talking about one-to-one, where you have one node communicating to the other node, and that's it. We also have a multicast system, whereby we have a one-to-many, whereby one node would transmit to many nodes, but these many nodes could be subscribed. For an example, I will share you the difference between broadcasting and broadcasting. Think of an example like where we have these um, pay TV systems like GoTV or what is it called? DSTV. You see, the transmission which is made by DSTV, for example, it is sent to many, but those who receive it are those who have subscribed or can be identified by that system. When you compare it with broadcasting, where we have an example like ABC, which broadcasts to all. ABC will broadcast anybody or any node which has the capability to receive that signal or be able to receive it because it is one to all. That is the difference of these communication types.
kuliko vile zimeachana hivi.
Then the we have the sender, the receiver, the medium, the message, and the protocol. Those are the same which we are going to describe as we move on. When we are talking about the sender, is the one who originates the message. The medium, the one which carries the message. The receiver, he receives and translates it by the set of protocols, which are rules agreed upon between the sender and the receiver. And then the message is the actual content which is being transmitted. When we are looking at these communication types, also the data will flow from the sender to the receiver. And this data flow can also be divided into three types. There are these three types of data. The first one is what we call simplex, whereby the flow of data or the direction of data is one. There is only flow of data between the sender and the receiver, and it is only the sender who can receive. The receiver not send back. Think of it like the TV transmission. The TV set will receive them, but they cannot respond back. Duplex, the direction is bidirectional. That is, the sender can send a message, the receiver can respond, but it is one at a time. They can't communicate simultaneously. It is one at a time. Think of the police walkie-talkies or the security guard systems, whereby one has to communicate over the channel. Once the channel is free, then the respondent can communicate back through the same channel. Then there is full duplex, whereby it is omnidirectional or bidirectional, meaning that both the sender and the receiver can communicate at the same time or can transmit back and forth simultaneously. Think of a telephone call whereby someone is talking and the other one is responding, or a video conference where someone and the other one is responding. So those are the cases, and the examples are there in slide number 10. So what determines a good network, or what determines the goodness of a network? When we are saying this network will enable proper communication or proper data communication, what is that? What makes it a good network, or what can we say this is the best network? One of them is performance. That is one of the metrics which is used to measure the performance of a network. And this one is dependent on the network elements, especially the hardware and the software. Later, we will come back into this and see the network elements. It is measured in terms of delay and throughput. When we are talking about delay refers to the time taken for a message to leave the source and get to the destination, or the time taken for the message to get to where it is required to get. Throughput is the capacity of that network. If it is a link between two nodes, what capacity can it carry? And when we are measuring it, we measure it in kilobits per second, or the capacity, which is what we measure data in. We measure data in terms of megabits or kilobits or whatever it is. And those ones we are asking at what rate in time. Just like you can say, this pipe of water is pumping 2 liters in 2 minutes. That is the same way we can say this channel link is transmitting or is able to download 2 megabits of data per second. So that is what we mean by throughput. What is the capacity of this network? Then the next one, the next performance metric is reliability. That is, what is the failure rate of these network components? If it is a router, if it is a switch, if it is a hub, what is the failure rate? And this one is measured in terms of availability or robustness. Is this network going to be available if there is a failure? We will soon be looking at the different types of network. We normally talk of topology. We say if the link breaks, then the whole network is down. Compare that with a star topology, whereby if one link breaks, the rest of the network is working and there is no problem. So that is the difference between reliability in terms of availability. Is this network going to be available even if there is a breakage? And that compares with robustness. How much can it withstand? How much can it be able to withstand effects of a failure, effects of an attack in a network? We will look at attacks and we are looking at network security. Then the physical structure will also determine the goodness of a network. Here we are looking at the type of connection and the physical topology. These we will look at in a while and understand how they affect the goodness of a network. And then security, that is data protection against corruption or loss of data. And this could be due to errors or it could be due to malicious users. So, slide number 13, we can classify networks in terms of size. That is the first classification criteria we normally use to classify networks. By size, they could be local area networks, they could be wide area networks, metropolitan area networks, campus area networks, personal area networks, so on. By structure, we mean the functional relationship between the nodes on that network. We usually have a client-server relationship. We also have a peer-to-peer relationship. Then we have a third classification by topology or the physical layout of the network, or how is the connection made in the network. So a local area network will consist of a few devices, but all of them will have to be connected within a radius of less than a kilometer. That is the basic description of a local area network. It covers an area of less than a kilometer. The systems are close to one another, and most likely you will find that that network belongs to one organization. So it could be an office, a school, a laboratory, or anything. So cables can be used to connect, or Wi-Fi can be used to connect because the devices are close to one another. When it comes to a wide area network, this one covers a wide geographic area where we are connecting cities, states, countries, or the global connectivity. Here we normally use the internet as an example of a wide area network because the internet is the global connectivity of all the devices across the network. So that is what it means. Alan Gitao is asking me, how many computers can be used in a local area network? That depends. A local area network can have as few as 2 computers and can have as many as hundreds of computers. So it will depend on the kind of connections you are making or the kind of network you're going to set up. Like we will see as we continue, the kind of network that you set up is the one that is going to determine the number of computers which you can set up in a local area network. So as long as they are within a radius of 1 kilometer, it doesn't matter the number. It is going to be a local area network. So like I had said, the internet is a good example of a wide area network. Then we have the metropolitan area network. Okay, let me mute everyone so that at least we are able to hear one another. Yes, I think that one is done. So we can only communicate now via messages so that we can be able to hear one another. I hope now it is clear. So a metropolitan area network is the network we find between the large area network and the local area network. Normally, it is within a city, or it ranges between 5 kilometers to 50 kilometers. And what normally happens, here you will find several local area networks or private networks have been now put together so that they can be able to share resources. The basic area here is to share resources. For example, you could be sharing an access point which is from a single service provider, an ISP. If it is within a town, you could find all the users within that town are connected to one ISP. So at one point, they will be connected to that access point or to that router, and that router now creates a metropolitan area network covering a larger area than that covered by a local area network, but a smaller area than the one covered by a wide area network. So the data rates are moderately high, and the metropolitan area network, it is the service provider who sells these services to private users or organization users so that they may be able now to connect. So it facilitates for sharing of regional resources. Why would an organization that is small and doesn't have enough capacity to afford its own connectivity to invest in one? It can just piggyback on an existing access point and it is able to connect. So a metropolitan, this is a diagram of an example of a metropolitan area network, which will now enable connecting to the rest of the internet. Now, a campus area network in slide number 18. Okay, an example of companies that use wide area networks and metropolitan area networks. Okay, so when we are using wide area network, like I just said, is that a wide area network is the global connectivity. The internet doesn't belong to a single user or a single company. That is one. Because it is different private entities which are connected to different service providers, and these different service providers now form the global connectivity. So the wide area network and the metropolitan area network, what they normally do is to enable these companies use the networks. Like we know we can use the internet to connect to a private network remotely, for example. This is where we start talking of VoIP, examples of VoIP, whereby companies can now access their private networks remotely from elsewhere through the commercial network or through the internet, but they are accessing it privately. So the internet or the wide area network and the metropolitan area network, their basic function is to enable or to facilitate connectivity for companies, because a single company cannot create a wide area network, but it can connect to a wide area network and be able to access many users or be accessible to many users across. So I hope that is clear, Joshua Juma. So let us continue with a campus area network. Now, a campus area network is just a local area network. But here, the difference is that the size of the local area network has grown beyond the 1 kilometer limit. It could be a network belonging to one institution, like a university, but this university is spanning several kilometers. That is why we call it a campus area network or a corporate area network, because it just belongs to one organization, so it easily could be a local area network. But since it has gone beyond the 1 kilometer radius limit, then it becomes a campus area network. Then we have the personal area network, or the PAN, and this one is a network that enables communication between computer devices near a person. Now, the main attribute here of a personal area network is that it doesn't go beyond a few meters, 2 to 3 meters, depending on how powerful your gadget is. Then 2 to 3 meters is what will create a personal area network. You could see things like the USB, the wireless like the infrared, Zigbee, Bluetooth. Those are some of the examples of wireless personal area networks, how they can be created. Mostly, these personal area networks are also temporary. They are created on a need base. And later, they have now become, they have developed another name, which we call ad hoc networks. Ad hoc networks, yes, like tethering, and Bluetooth. That is true. Yes, and hotspots. That is correct. Those are some of the examples of personal area networks, which are like temporary. You create them on a need basis, and once your transmission is over, the network is disconnected. Mostly, you will find that they are wireless based. Those are the networks now we are calling ad hoc networks. They will be created places where there are no resources, or setting up resources is expensive, or it is a temporary network. So you create it and you are done. Although ad hoc networks now have grown to cover a larger area, but here when we are talking in the case of a personal area network, then it covers that range of a few meters. Then we come to the second classification, which we were calling the relationship. One computer which is powerful and it controls the resources and functions of the network, and we call it the server. And all these other computers or nodes will connect to this computer or node to request for resources and run programs on the server. So they become like they are requesting, and once they request, the server responds to their request accordingly, depending on their access capabilities and so on and so on. So that is something we will cover later. Then we have peer-to-peer network, which is the opposite of client-server network. All the nodes or computers on that network are equal. There isn't one which is superior to the other. They share files, they share data. Computers in another organization remotely, just because they have internet connection, so that they can use the processors in those computers remotely. So that is what we refer to as processing power, network bandwidth, disk storage space. Like what we are doing nowadays, there is a lot of storage which is being done offline. You have heard of disk storage, like what do you call this? This Google sharing, what is it called? Dropbox. An example of a file sharing app, which is very common. But what it does, you are storing your files somewhere remotely, but you are able to access them as if, yes, and Google Drive, as if they are on your local machine or on your local maybe smartphone and so on. So that is what creates a peer-to-peer network. You are accessing another device remotely, you are getting files or you are getting resources from that device and you are using them on your local device. That is what refers to it as a peer-to-peer network. Then we come to the third category, whereby we categorize networks in terms of the connectivity or topology. Here we have these 4 classes, and there could be more depending on how the network is set up. We have the star, the mesh, the bash, the ring. When we are talking about the mesh topology, all computers are connected together. An example is the internet, like we are saying, there is connection all over. You lose one connection, there is another connection elsewhere. So that is the beauty of the mesh topology. But then a lot of cable is used and it is hard to set up. Like we have said, the internet doesn't belong to a single user. So the benefit is that not a single entity will be used to build the mesh topology, but nodes will be able to join the mesh topology and it ensures delivery. So the principle of delivery is adhered to by a mesh topology. Then we have the star topology, whereby all nodes or all computers connect to a central hub or a concentrator. And this hub is the one now which is used to forward the packets which are being delivered there to the destination. So in terms of advantages is that it is easy to set up and one cable cannot crash the network. But when it comes to disadvantages is that a lot of cable is used, and if that central connector or the hub or the switch, whichever device you are using, crashes, then the entire network is crashed. But this is the most common topology which is used in the present day. Then we have the bus topology, where we also call it the linear bus. All cables are connected together, and that one cable connects all these other nodes. If it disconnects or if it is terminated, then the entire network is down. It is easy to set up, small amount of wire is used, but it is very easy to crash. This was the initial topology which was used to connect devices, because the other. Then we also have ring topology. Ring topology, all nodes are connected in a circle. And then a token, it is like a protocol, which we call a token, which is used now to transmit data. Nodes must wait for the token to send, and nodes transmit on a first come, first serve basis. To send is known, and there is no data collision. Like we will see later when we are looking at different protocols which are used for connectivity and data transmission, collision is very key. Then in terms of disadvantages, it is low. As the number of users grow in that network, then it means that wait time increases. Because let's say if you have like 20 users in a network, it means if you are number 18, you will have to wait for the first 17 users to transmit, then you will transmit. Imagine the number increases, the number of users, then the wait time increases, and the network becomes very slow. Lots of cable is also used. Then we also have the tree or the hierarchical model. This is the one you find now the network is being based on, whereby you find that at the lower level, we have the access layer. I don't know if you are able to see where I'm showing. When I am clicking, I don't know if you are able to see. You can confirm if you're able to see. The access layer is what we can also call the user level or the private level, whereby users are accessing or are requesting for information and data from servers. At the higher level is where we find the distribution layer, The distribution layer, you find different service providers and different types of network architectures being set up there, and they enable creation of what now we are calling the internet, different service providers and connecting to the backbone of the internet. And then the core layer is where you find the entire internet. So it is an hierarchical setup which enables now devices or users to connect to the network with ease. And that is how the internet is normally made. We will come back to this architecture in more detail. This first lecture is a brief of the entire course. So the hierarchical model involves dividing network into discrete layers, and this branching factor enables point-to-point links between the levels of hierarchy. So the advantages is that it is scalable and it is easy to implement. Like we are saying, users or nodes can plug in with ease when you have the levels. So there are three terms here, which I hope you are aware of: the internet, the intranet, and extranet. Very important to note. When you're talking about the internet, it is a global connectivity, like we have said. The internet will be a private network. A private network that is under the control of a single administrative entity. And this intranet cannot be accessed from outside. It cannot be accessed within the institution or within the, what do you call them? The protocols enabling the access of that network. The difference between it and an extranet is that an extranet is also limited to a single organization, but it has limited connections to the networks of one or more than other organization. So you could have two private networks. You are not able to see my presentation. Okay, let me see what the problem is. Now you're able to see it. So, we continue. I was explaining the difference between an intranet and extranet. We're saying both intranet and extranet, they are private networks. These private networks, one of them has a single administrative entity, that is an intranet, where you will need to be authenticated before you get that into that network, like a web browser, where you will need to give your username and password so that you can be able to transfer files or whatever it is. Then an extranet, we are saying that is also a private network, but now this private network allows access to itself from another private network or from another organization like you have two organizations. Let me like Naivas supermarket, for example, and you have another organization like Mumias Sugar Company. Now, both of them have private networks. These private networks have systems which can be accessed. We are looking at a system like an ERP used by Naivas Supermarket. Maybe Naivas Supermarket has allowed Mumias Sugar Company to be able to access its network, its inventory, its ERP over the network to check. Whenever the sugar levels go down, Mumias Sugar Company should deliver automatically. So by Naivas network allowing Mumias Sugar Company network to access its own network. That is like integrating the two systems for notifications. Then it creates an extranet. So I don't know if that has made sense. Maybe you can tell me via comments the difference between an intranet and an extranet, if it has made sense by what I have explained. I have said that an intranet will be just a single network, a single organizational network, and this single organizational network, which has resources, maybe files or whatever information is stored there, can be accessed remotely, but via authentication, that is by individuals. When it comes to an extranet, it is also a private network, but here now, this LAN will allow another private network belonging to another entity to access its network. So I hope that is very clear. That is why I put them there in this presentation. So this is the hierarchical organization of the internet. So if it has not made sense, you tell me, I will be able to clarify again. And then the hierarchical organization of the internet, that is what we normally have. We will come back to this when we are looking at how communication takes place in the layered model and the different types of addresses. And then the last thing we have looked at the medium and all of that, the sender and everything. The last thing we need to understand in that element is protocol. Protocols are very important. A protocol is synonymous to a rule. For these two nodes to communicate, for these two nodes to be able to exchange information or to transmit data, that is where now protocols come in. These are a set of rules that govern communication. They determine what is being communicated, how it is being communicated, when it is being communicated. And those three things form the syntax, semantics, and timing. So syntax is the structure or the format of the data. Like we were saying, data have different formats. If you remember, when we were starting the class, I was looking at the comments. Rose Charity is asking whether when Safaricom sells its internet, it also becomes an extranet. No, at that moment, Safaricom becomes like a service provider, an ISP. When we are looking at an extranet, we are looking at you accessing, let's say it is an organization like what? When we are looking at the example of Safaricom, we could give the example of what? These people are using till numbers and all of that. You see, a till number will connect to your bank account and to the Safaricom account. Who is not able to hear? Is everyone able to hear my voice? Oh, Agri Keegan was saying they can't hear. Okay, okay. So I was trying to explain the example of Safaricom just to show the difference between an extranet and an intranet. We are saying in this case, when Safaricom is selling its internet, it becomes a service provider. For it to become an intranet or an extranet is whereby Safaricom is able to access your bank account to send money, like using the till number. When somebody pays, that money goes to your account, but it is being transferred there from a Safaricom system. So this Safaricom system is on another network, and the bank system is on another network, but they need to communicate, to exchange information, maybe to say money has moved from your M-Pesa account to your bank account. So in your M-Pesa account, you are going to reduce the amount. In your bank account, you are going to do what? To increase the amount, or vice versa. So when these two systems are communicating, those are two different networks, and they could be in two different lands, local area networks, and now they have created an extranet. I hope now that becomes clear with that question of Safaricom. So we go back to the elements of a protocol. We were saying syntax is like the structure of the data, or the format of the data. Is it going to be in text? If it is in text, how is the text represented? You know, how are the data bits presented? As we continue, we'll look at data representation in more detail, and we will see how is data represented, the different data types and all of that. Then there is also the semantics, the interpretation of the bits, because we are saying if it is a user will type something. They will type it and it will appear in the normal English language on the screen. But what is happening when it is being transmitted, that information has to be translated. Now that translation is what we are calling semantics. How is it going to be interpreted? If it is a bit is like a zero, what does a zero represent? What does a one represent in that kind of a structure of data? Then there is the aspect of timing, when data should be sent, the speed at which data should be sent, or the speed at which data should be received. This is important because timing is important because you find that some devices in the network are not transmitting at the same speed, or networks do not transmit at the same speed. You could be on your machine and you're transmitting at 100 megabits per second, but the receiver node is receiving at 10 megabits per second. So what will happen in that case? You need to do synchronization, and timing is synonymous with synchronization, making sure that this information is going to be delivered at the speed at which the receiver can take it. If not so, then it will be corrupted. That is why we need what we call, what is it called? Buffering. The same, you could be transmitting at a lower speed and the recipient is getting the information at a very high speed. What happens? There needs to be timing as well, or synchronization between the sender and the receiver. So protocol will be able to have those elements which guide now how transmission is going to take place in terms of syntax, semantics, and timing. So I hope also the aspect of protocol is very clear. So okay, thank you. Rose Charity says they are simple to understand. I think that is good. Now, I wanted us to proceed. I had just sent the lecture 2 before we started the class. I wanted to know, can we proceed with the second lecture? And then there is the aspect of, now I think we can discuss all of us before we continue, as we have a break. Then you tell me if it is okay, we can continue, or also wanted to know, is it okay we move the class to some other time? Because as you saw on the WhatsApp chat, some people are requesting that they are working, and if it is moved to the evening, it will be of help. So what do you think? I wanted to hear your suggestions. Okay, I see Abdirashid says evening from 5:30. It's better in the evening. Gitao Garson says at night is okay. So I think everyone says in the evening it is okay. So then I think our next class, we will agree that it will take place from 5. Is that okay? Yes, yes. Okay, then I think it is agreed. We will be meeting from 5. So next week on Thursday, 5 in the evening. Now, who will be our class rep? So that they can be reminding us on WhatsApp like 30 minutes before tunajipanga. Okay, somebody says Stella. I think then it is agreed. Okay, I agree. Stella, it is okay. We will now continue with you as our class rep. Now, I don't know. You can send me a message privately, Stella, and then we see. Yes, for the recorded classes, I will do. From next week, we will have the recorded classes. Yes. So next week, we will meet from 5 p.m. So thank you, and let's meet next week. The other communication let us do on WhatsApp. Then Stella will send me a message on WhatsApp. Thank you.